Hi, I'm Juan Villalobos, and my exercise is number 2 in the Collaborate activity. In here, I needed to first add these two radicals. When I try, first I simplify them, then I get this. So here I get out with these two outside the radical. I get out all the numbers that can be divided by 2. I stay with this, and these two I added them, and I get 12x2 and 6x as a radical. Then for the next one, I get this quantity, and I needed to rest it to this. First, I simplified it and get out the numbers I could get out, like here, with dividing them by 2. And I get this, I rested it, and I stay with 9x2 and a radical of 6x. And in the last part, I needed to change all the x by 100. First, it was 9 times x with an exponent of 2, so I changed it and put 9 times 100 with an exponent of 2. I get all this, so I simplified it, and here there's some imaginary 2, and I get out all the numbers that I could get out. I stayed with this, and I do the operation, and I stayed with 900,000 with a radical of 6. Thank you.
I'm Esteban Gandara, and I got the first question. To answer this question, you need to simplify all the radicals and then add them together. The formula to find the perimeter is to add all of the sides together, which will be 5 cubic root of 54, 2 cubic root of 16, cubic root of 128, and 3 cubic root of 250. To simplify this, you need to do all of the radicals. On the first one, the simplification is 5 cubic root of 2 multiplied by 27, which results in 15 cubic square of 2. On the second one, the simplification is 2 cubic root of 8 multiplied by 2, which results in 4 cubic root of 2. On the third one, the simplification is 3 cubic root of 64 multiplied by 2, which results in 4 cubic root of 2. And the fourth one, the simplification is 3 cubic root of 125, which results multiplied by 2, which results in 15 cubic root of 2. Then you need to add all of this together, and the result is 38 cubic root of 2. Here are all of my procedures, and
I'm going to explain the solution for problem number 3. You have to find the area of the rectangle. For that, you will need to multiply the base for the height. First, you have to put the binomials in a multiplication. Then use the FOIL method. Multiply the first two numbers, 5 square root of 6 and 2 square root of 6, which equals 10 square root of 36. Then the outer numbers, 5 square root of 6 and 3 square root of 2, which equals 15 square root of 12. Then the inner numbers, minus 3 square root of 8 and 2 square root of 6, which equals minus 6 square root of 48. And the last numbers, minus 3 square root of 8 and 3 square root of 2. Then you see if you can solve every square root. Like in 36, you can solve it, it's 6. In 12, you can't, so you divide it into numbers. In this case, I used 4 and 3, and the square root of 4 is 2. 48, it's the same, you have to divide it. I use 16 and 3, and you get 4 for 16, the square root. And 16 in the last one is 4. The next step is to simplify your answer. You put all the square roots you can solve and all the multiplications there. 10 times 6 plus 15 times 2, which equals 30, and the square root of 3. And then minus 6 times 4 and the square root of 3, And last, minus 9 and 4. You get as a result 60 plus 30 square root of 3 minus 24 square root of 3 minus 36. Then you see for the similar numbers like 60 and minus 36, you can subtract them. 60 minus 36 is 24, then 30 square root of 3 and minus 24 square root of 3, you can do the same. 30 minus 24 is 6, so then the final result is 24 plus 6 square root of 3. That's the area.